Hi everyone, my name is Olivia Smith, and I'm a senior here at the University of Minnesota, and I'm actually on my final semester, so it's really the final stretch right now. And I'm here today to present to you my final project, Spellcasting Using Gestures. So first, before I go into my project specifics, I would like to define what exactly is a gesture. Gesture being in the natural language is subject to being interpreted a variety of ways, and as such, it's important to nail down what a gesture is in the field of VR, or gesture command systems, as well as how we define what a gesture is. So, to do this, I turn to the related works on the subject. Hummels and Stapper specifically has defined 4 aspects to a gesture with regards to human-computer interactions, and they are especially applicable to my project at hand, so I define them here. The first one is space, or where the gesture occurs. The second is pathic information, or the motion of path taken by a gesture. 3 is symbols, or the sign indicated by the gesture, or what the gesture symbolizes. And effects, which is a little bit more ambiguous, the emotional aspect of a gesture, which isn't entirely applicable to my project at hand, but is still important to mention nonetheless. An example of an affect in a gesture could be tracing a heart with your finger. That can have an emotional charge, and as such has an emotional aspect. In the related works, there were also 2 different criteria or categories that were found in defining what a gesture is. So first there was the level of detail, which could have been boiled down to maintaining the hand position and orientation. The fingers, the arms, or even larger body parts came up a couple times. And in addition to that, there was static or dynamic. So, a static gesture would be like holding a peace sign or pointing without moving your hand. Dynamic, on the other hand, requires there to be some form of motion. So, like waving your hand back and forth to say hello, that would be a dynamic gesture. The literature also touched on how a finer degree of detail in the task indicts user fatigue faster, which was also touched on in the course material, so it really wasn't surprising to see that in the literature. And as such, minimizing fatigue is crucial for maintaining the novelty of such a gesture system, and of course, maintaining the whimsy involved in spellcasting. The literature also kind of suggested that general hand motions are most widely used in gesturing. And with this in mind, in addition to the technology at hand or the Oculus Quest controllers, we chose to use hand position orientation as our level of detail. And also, since spells are kind of a variety of points, we also categorize our gesture as being dynamic. There were also many input styles touched on by the literature, so camera-based sensors, inertial sensors like what's inside a Wii remote, and spatial controllers such as the Oculus Quest controllers were used, and there were also many comparison methods. The first one was the Hidden Markov model, or the HMM, and that's a statistical model that is highly accurate, as well as great for large data sets. As such, it's often used in machine learning algorithms that detect gesture commands. And as you can imagine, that's also a hot topic in the VR gesture command scene right now. So, on the other hand, there's dynamic time warping, which is better suited for smaller data sets, but is still highly accurate and is what we used for this application. I will go into greater detail about what dynamic time warping looks like in the implementation phase of this presentation. So now that we have a definition for what a gesture is, we can move on to the fun part, which is the spellcasting demos. So the first spell we have is an elemental spell. And I'll note that upon the beginning of a spellcast, a twinkling sound loops, and upon successful validation, you are immediately greeted with a louder twinkling, which is followed by the spell's unique animation. In this case, it's rocks floating up above the user and rotating around their head. Oops. Moving on, we've got the rebirth spell, and Here is a demo of that. Here we get a little visual of the tutorial system, which I'll go into further detail later about. It's just a simple swirl, and it triggers, as the name might suggest, like life to kind of quote-unquote birth around you. Now on the next slide, we have the protection spell. And here we can also see that tutorial again in action. And this one triggers kind of a force field to conjure up and spin around the user, as the name might suggest, in protection. Moving on. So, as I mentioned before, we have a tutorial system set up, and what's neat about it is that it can actually be started at any user position or rotation on the map. So you don't have to worry about not being in a certain beginner area or anything. Having a tutorial such as this can kind of ease the learning curve of learning new gestural commands, because spatially it can be very difficult to replicate something if you don't have a reference. So this is what this seeks to have a solution to. And it does so by showing the expected path it takes with the gray line. It's kind of hard to see in the image, my bad. And also the orb that travels along the path kind of depicts the expected motion speed of the controller. Project. So really the core motivation was immersion. There's nothing like just being able to gesture out your own spells after seeing it done in movies and TV shows all these years, and it really provides an experience like no other. And since it's based in world space, it's kind of realism with a fantasy twist with the spellcasting aspect. And what I didn't mention before was how the symbolism in the spells actually come from pagan witchcraft. So the star is actually a pentagram, where each point represents a different element, hence the name Elemental Spell. Unfortunately, I was only able to squeeze in the stones as being the earth element in the animation, which would lead the other elements to be kind of an extended goal, rather. The Rebirth spell, on the other hand, as you can imagine, is kind of tied to regeneration in life itself. And I always butcher it, but the Trikirta, or the image on the bottom, loosely in some interpretations means protection, hence the protective force field around the user. And the motivation behind the tutorial was how difficult it can be to conjure up gestures just out of the blue in your own imagination with no reference. So providing that tutorial was really important to help easing that learning curve, as I previously mentioned. Feedback. So like the audio cues. People like to be heard and responded to. They like to know if they've done something right or if they've done something wrong as quick as possible. Audio cues are present, as you heard, but they are admittedly a buggy on the Oculus browser. Sometimes they don't play, the Oculus browser mutes them, and if you re-enter with the sound on, the spellcasting sound loops indefinitely. Visual cues would definitely be ideal, especially for accessibility reasons, just in case we have any deaf users out there, in addition to the fact that we are visual creatures by nature. And now we transition to implementation details behind this project. So kind of an overview of the general gesture recognition logic. We first trigger this system by having the user press and hold the trigger on either controller. This begins point tracking, and it also draws lines while tracking the points that connect each line, so we can get that spell feedback to the user. And when the user releases the button, if the spell cast is too long or too short, we immediately fizzle, since it's not really worth comparing to our predefined lines. Otherwise, we pre-process the spell line so that it is in the center of the map with a neutral rotation. We do this so we can have a consistent way to compare against predefined lines. We then compared this process spell line to the predefined lines with dynamic time warping, and we returned the predefined spell closest to the Castus spell. If none of them are below a certain distance threshold, however, we indicate a fizzle, since this indicates that none of them are close enough to a line, to a predefined line. And so preprocessed data, graphics math 101. So this preprocessing the data is motivated to allow us to compare spells anywhere in the map. And what we have at any given moment is the user's current position and rotation in world space. So to translate a point sequence or a transform node to the center of map with a neutral rotation, we either do the following for each point or just on the transform node. We subtract the user position from the point and rotate around the center of the map using the inverse rotation of the user. And now I'll get into dynamic time warping, which is a statistical means of comparing lines of varying lengths. It's also used in other contexts as seen on the right, such as sound analysis. It works by building a distance matrix and returns the total distance between lines. We can use this when determining which, if any, gesture line fits and which fits best. So if you kind of look at the image on the right, we can see mappings of different points, the mappings indicated by the lines of where each portion of the line best fits with the other one, which is also replicated in the image below and just a different means of illustrating it. So the comparison method needs some tuning. Needless to say, we need to figure out what distances work best, and here's an example of what should have fizzled, but did not, unfortunately. So this just stemmed from not handling the distances correctly, and apparently that fizzle was indicated a small enough distance in comparison to the elemental spell line, thus triggering the line. The animation, more rather. And now we move on to concluding remarks. So there were a couple of proposal ideas that I didn't quite meet. One of them being the immediate visual feedback of whether a spell has been identified correctly or not. And what I found were that the triggered animations were very costly and would frequently cause frame rate drops, which is very bad in terms of VR, since it can cause cyber sickness and just a general break in immersion, as covered in the course materials. And since Babylon.js didn't quite have an easy and slick way for me to either change the glow effect or change all of the line meshes associated with the casted spell, it would have been even costlier to change the color of the spell. So I decided to be a little bit more conservative and ease the frame rate issues by just dropping the feature altogether. Predefined spell line training also kind of ended up getting passed. That was due to spending my time on the tutorial instead, and which I thought was a better use of my time, since even if there are nuances in the spell line that might look a little strange, at least the user knows what's expected of them and knows how they're expected to perform the spell. So I think that was time well spent. A few lessons learned. Number one, kind of get this feeling at every project I complete. Avoid crunch time as much as possible. You kind of end up just throwing whatever sticks, and it might not be the best information flow. And so, in hindsight, there could have definitely been more optimizations and stuff like that. But unfortunately, due to crunch time, you kind of just have to roll with it. And number two, you can't do everything. Whether it's in terms of workload and how long some of these tasks take to implement, or just the sheer processing power of some of this hardware. You just can't do everything. And number three, frame rate is king. Being in the Oculus Quest and seeing the frame rate drop and just seeing it affect the way I move my head and everything like that definitely was disheartening, and so I learned really fast that having a high frame rate really is exceptional. And number four, animation is hard. It's so much pixel pushing. It's nice to have pretty assets, and just getting the frames to line up, it's a challenge, but it was a fun challenge. And so here are some of the references that I pulled from my literature review. You can take a look at any of these works if they interest you, the titles interest you. Here's a couple more. And finally, thank you. It's been a hard-working semester, but a great one. This class is genuinely so well designed for the online atmosphere, which is an extremely hard thing to do. So thank you, Professor Rosenberg. Thank you, Tongyu. Your help has been essential in my learning, and I've got to build some really cool things because of that. So, thank you.